Yeah. Now, the next problem, a bag contains 5 red and 3 blue balls. Again, when it comes to a combination of two or more colors, we will be using combinations here to solve the problem. So, a bag contains 5 red and 3 blue balls. Two balls are drawn from this bag. What is the probability that, so two of the balls are drawn at a time, out of 5 plus 3, out of 8 balls that are present, out of 8 balls that are present, 2 balls are randomly selected. Okay, so out of these 2 balls, what is the probability of getting a red ball? So how many red balls do we have? We have 5 red balls and 3 blue balls. So 5 out of 5 red balls, we are taking 2 balls. That is one combination. The, excuse me, the other combination is, out of total 8 balls, we are taking out 2 balls. Okay, so that is the second combination. So here, while you're solving the combinations, you will have to take the favorable event. What is the favorable? Out of 5 red balls, we require the red balls to be the answer. So out of 5 red balls, we are selecting 2. So this is the favorable event. And what is the total number of or the sample space, total number of events or sample space? We have 8 total balls. Out of that, we are selecting 2 balls. Okay, so this is the favorable events and this is the exhaustive events or the sample space. We are not deviating from the probability formula. We are making sure the probability formula is followed, but then that probability formula will be followed in every situation. Okay, so that is the first one. That is the probability of getting the red ball. Now this 5C2 and 8C2 is supposed to be solved. Now 5C2, that is nothing but n factorial divided by n minus r factorial into r factorial. Okay, you have to solve using this formula and then you will get 10 as the answer, and for 8C2 you'll get 28 as the answer. I think I have solved this first part. Now moving on to the next one, that is probability of getting blue balls. Now similarly here we have 3 blue balls. So out of 3 blue balls, we are supposed to select 2 blue balls. Now the first scenario was selection of 2 red balls, right? So that is a different thing. Now we are supposed to select 2 blue balls. Now how many total blue balls are there? There are 3. Out of that, 2 is being selected. Okay, and then that will be our favorable events. This will be our favorable events. Now what is the sample space? Sample space is total number of events, so everywhere the sample space will be 8C2. Okay, now if you have to solve 3C2, use the same formula, that is n factorial. So 3 factorial divided by 3 minus 2 factorial into 2 factorial. So here 3 into 2 factorial divided by 3 minus 2 is 1 factorial into 2 factorial. So now I can cancel 2 factorial and 2 factorial. So 1 factorial is nothing but 1. So 3 by 1 is 3. How come they got 6? Next, 8C2 is 28. Again, this should be 3. 3 by 28. Okay, so always use the formula of n factorial by n minus r factorial into r factorial. You should use this formula only and then solve for the combinations. So that is the probability of getting the blue color is 3 by 28. Just write it in the fraction form only, 3 by 28. Now understood the second question, first two questions. Any doubts here before going into the next part? Understood? Reply quickly. Okay. Now moving further is one red and one blue ball. Now from a bag of 8 balls that is there, we are selecting 2 balls. Now this 2 balls will be one red ball and one blue ball, which means both are different color balls. Okay, now when both are different color balls, what is my favorable event? Out of 5 red balls, I will pick one. That is, the one red ball is the favorable event, and out of 3 blue balls, I am picking one ball of blue, that is the favorable event. Now why am I saying favorable event? Now let's take for example, you have gone to a function, some family function you have gone. Okay, now usually in functions they'll do variety of sweets. Now say suppose you love Mysore pak, your favorite sweet is Mysore pak. Okay, now when suppose in that function also they have prepared Mysore pak, that is your favorable event, because it is favorite for you, and you can eat at least 2 to 3 pieces of Mysore pak, how much ever you want. If they are known person, you can also pack for home, that's a different case. Whenever you get what you want, that is a favorable event. Now here in a bag of 5 plus 3 balls, I am picking 2 balls. Now if that 2 balls, one ball is red and one ball is blue, that is my favorable event. Okay, so in the numerator we will be giving the favorable event, and in the denominator we will give the sample space. Sample space means all the possibility. Now say take the same sweet example. What are the possibility of sweets being prepared in the function? They can prepare jamun is difficult. They can prepare kheer, that is your paisa, different types of paisa, obbatu. Then you can have some badusha and jangir, jalebi, Mysore pak, barfi, khaju barfi, Horlicks barfi, and all that. So there are so many. That's a long list of sweets that is there. So that is your sample space. All variety of sweets is a sample space. But in that, preparing Mysore pak, which is your favorite, is your favorable event. Understood? That is how we are selecting. If you don't remember any of this thing, remember the sweet example. You will be able to relate it. Okay? That sweet may be any of your favorite sweet, or your food. Any of your favorite food also would work. So here, out of 5 red balls, I am selecting one red ball because that is a favorable event for me. I am expecting one red ball and one blue ball there. Okay, so out of 5 one has to come to my hand. Out of 3, one has to come to my hand. Okay, and what is the total possibility? There are 8 balls where I am supposed to select 2 balls. Now this 8 balls have both red as well as blue. Adding them together only is called as 8C2. Okay, now 5C1 is nothing but 5, 3C1 is 3, divided by 8C2 is 28. We have already solved this from the first sub question. Okay, now 5 3s are 15. 15 divided by 28 will be the probability. So what is the chance of me getting one red and one blue ball? The chance of getting one red and one blue ball is 15 by 28. Understood? Any doubts in this question? Okay. Now, next question. Now, after this, the last question that is there is, if both are same color. Now, both are same color means it can be red also, it can be blue also. We don't know. They have not given which color exactly you will get. You are taking two balls randomly from the bag. The two balls may be red color, the two balls may be blue color. Now, understand the difference. When they have only given one red ball and one blue ball, we have done the multiplication here. Okay, but when they are saying both are of same color, we are separately calculating for red, we are separately calculating for blue, and then we are adding them here. So red balls are separately calculated, blue balls are separately calculated, and then we are adding. Clear? So now let us see how this will be done. Now in a bag of 8 balls, when we are supposed to pick two balls of same color. Two balls of same color means I can pick two red balls or I can pick two blue balls. So first let us understand if we pick two red balls. Now how many red balls are there? There are 5 red balls. So out of 5 red balls, I am selecting 2. This is my favorable event. And what is the sample space? Out of 8 balls, I am selecting 2. This is the calculation for 2 red balls. Now similarly, the calculation of 2 blue balls. There are 3 blue balls, out of which I am selecting 2. And then what is the sample space? Again 8C2. Out of total 8 balls, I am selecting 2 balls. Now, what is the main question? Both are of same color. So, it can be either the red balls that has been selected, to both of them being red balls, or both of them being blue balls. So, that is why we add this and find the probability, where if we solve this, we get 16 by 28. So, the probability of getting two same color balls that either can be two red balls or two blue balls is 16 by 28. Okay, be careful in such questions where you will have to understand and solve the problem. Now here they have not given it clearly saying you have to take two red or two blue, right? So you only have to analyze it. Any doubts in this question now? Did you understand the last part? Okay, can we go to the next question then? Now, let's go to the next question. Now here, from a pack of 52 playing cards, 2 cards are drawn at random. Similarly, like that, okay, whenever they say 2 cards are drawn at random, 3 cards are selected, 4 cards are selected, now you will have a combination being used there. Okay, so from a pack of 52 playing cards, now we already understood how is that playing cards done. Okay, so two cards are drawn at random. What is the probability that they are ace? Ace is nothing but the first card, that is 1. And then what is the probability of it being a diamond, and what is the probability of it being a black color card? So this is the question. So first let us again revise how many cards are there. Out of 52 cards, you have 4 divisions, where you will have spade, club, heart and diamond cards, wherein each set will be 13 cards. Okay, these two cards are black in color, these two cards are red in color. So black cards will be 26 and red cards will be 26. Okay, and what is the series of the card? How will each set be? You'll start from A is ace, that is 1, and then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you'll have J, K, Q. This will be the cards series. Now what is that they're asking? From 52 cards, from totally 52 cards, they are drawing 2 cards in random. 2 cards will be drawn at random. So what is the probability of getting a ace? Now, out of total 52 cards, now listen here carefully, such questions can be confusing. Now, out of total 52 cards, now total 52 cards means spade will be 13, clubs will be 13, hearts will be 13, and diamonds will be 13. All of them will be mixed up. Now, out of the whole 32 card, when you are selecting 2 cards, where that both the cards should be ace. Now, how many aces are there in the 52 cards? That you have to first find out. How many aces are there? There is 1 ace in the spade card, 1 ace in the clubs, 1 ace in hearts, and 1 ace in the diamond. Now, how did we get 1 1? Because every card will have the same series. And if you see the first one here, that is A, that is called as ace. So for spade, they will have 1 ace. For clubs, they will have 1 ace. And then for hearts and for diamonds. So how many aces? 4 aces, right? So what is the favorable event? Out of 4 aces, that is ace cards, I am supposed to choose 2 cards. This is my favorable event. Okay, out of totally 4 cards, I have to choose 2 cards. But what is the sample space? What is the total number of cards? My total number of cards is 52. My total number of cards is 52. Out of 52, I am supposed to select 2 cards. So my sample space will be 52C2. But my favorable event is 4C2. How did I get 4? You will have one number card in, that is ace card in spade, club, heart as well as diamond. So totally there will be 4 cards in the set, and out of 4 I have to select 2 cards. Okay, so 4C2 you have to solve it. Please solve these answers, don't just blindly write them. So 4C2 is nothing but 4 factorial by 4 minus 2 factorial into 2 factorial. Okay, so 4 factorial is 4 into 3 into 2 factorial by 2 factorial into 2 factorial. So 2 and 2 factorial will go away. So 4 3s are 12, and then divided by 2 factorial is 2 into 1. So you'll have 12 by 2, which is nothing but 6. So if you see here, you have got 6. Okay. Similarly, find out 52C2. 52C2. 52 factorial divided by 52 minus 2 factorial into 2 factorial. So 52 into 51 into 50 factorial divided by 50 factorial into 2 factorial. So 50 factorial will get cancelled. Now multiply 52 into 51 by 2, you will get 1326. Solve every combination using the formula. Okay, and then the probability of getting the A's card is 0.0045, or you can just write it as 6 by 1326. You can either get it to the decimal form and leave, or you can just leave it at fraction format also. Okay, did you all understand the first question? Any doubts in the first one of getting the A's card? Okay, good. How about others? Others understood? Okay. Now, second one, let's solve it together. Concentrate. Now, out of 52 playing cards, again there are two cards which has to be drawn, but this time both the cards should be diamonds. Now, can you say me, in the pack of 52 cards, how many diamond cards will be there? Out of 52 cards, there will be 4 different forms: club, spade, heart and diamond. So how many total number of diamond cards? Good, Akila. Others, I want others also to answer. Each set will be of how many cards? So only Akila knows, is it? There will be 13 cards of each set. Okay, so there will be 13 diamond cards, 13 heart cards, 13 spade and 13 club. Okay, so here they're asking us to select two cards, and both the cards we are expecting it to be the diamond card. Okay, so out of 13 cards, what is my favorable event? Out of 13 cards, I am supposed to draw two cards. That is my favorable event. And when it comes to the sample space, it is same as the first one, that is 52C2. There are total number of 52 cards, and in that 52 cards, I am selecting two cards. So that is the probability of getting diamonds. Now solve this 13C2. 13C2 is 13 factorial divided by 13 minus 2 factorial into 2 factorial. So 13 factorial, you can write it as 13 into 12 into 11 factorial divided by 13 minus 2 is 11 factorial into 2 factorial. So if you see here, 11 factorial, you can cancel. So 13 into 12, 13 into 12 divided by 2 into 1. Now if you simplify this, you will get 78 as the answer. So the probability of getting a diamond card when you draw two cards randomly from a 52 card pack, it is 0.588, or you can keep it at fraction, that is 78 by 1326. Understood the second one? Any doubts in the second part? Second sub question. Understood, or you want me to repeat it again? Okay. Now, next one, that is black color. Now, out of 52 cards, who can say me how many black color cards will be there? Out of 52 cards, you'll have 26 black cards. Very good. How 26 black cards? You will have spade, spade and clubs. These two are black cards. So 13 plus 13 is equal to 26. So totally 26 black cards will be there. Now in the 26 black cards, we are supposed to select two cards randomly, and those two cards should be black in color. They're just saying black in color. They're not saying it should be specifically spade or specifically clubs. So it has to be 20 out of 26 cards, two cards has to be directly black color. So that is why we take it as 26C2, and the sample space will remain as 52C2. Now solve this using the formula n factorial by n minus r factorial into r factorial. If you solve using this formula, then you get the probability to be 325 divided by 1326. Understood the third one? Any doubts in this part? Wherein the two cards are ace, diamond or black color card. Yeah, correct, Akila. It totally 26 cards, spades and clubs. Very good. Can we go to the next question? Listen, the probability of an arrow hitting a target is 1 by 5. If one arrow is aimed at a target, what is the probability that the target is not hit? This is a different question. See, until now we have learnt what is the probability of getting a color, getting a card, what is the probability of getting different color cards or different color balls, right? But this question is talking about not getting it. Okay, when it is not getting it, it will become the opposite of it, or it's usually called as transpose. Okay, so let's read the question once again. The probability of an arrow hitting a target. Now you would have seen, if at all you would have seen this arrow shooting. You'll have the concentric circles. Okay, it will be neatly drawn. Okay, concentric circles. Now they'll have to shoot to this the center dot. How much near you, if you shoot to the center dot, okay, center dot, that you're so accurate. That is what they are saying. So that point is known as the target. Now they're saying the probability of hitting the target is 1 by 5. Okay, but what is the question? If one arrow is aimed at the target, now let's say we are doing the shooting competition. Now in the shooting competition, we have given a target. Now in that target, let's say here is the target. This place is the target. Now this target has to be hit by the person. Now we are not talking about will they hit, we are talking about they will not hit. Let's say instead of shooting here, the person will shoot here. The person will shoot in this place. Okay, now in this cases we will be using the transpose. So let A be an event of hitting a target and A dash be an event of not hitting a target. So if I say A is an event of hitting a target, then A dash, that is the transpose, will be the event of not hitting the target. So if the probability of hitting the target is 1 by 5, this is given in the question. We have not specially found out, it is directly given in the question. Okay, then what is the transpose of it? Transpose is nothing but 1 minus P of A. So what is P of A? P of A is 1 by 5. Now find the LCM for 5. So 5 minus 1 by 5, which is nothing but 4 by 5. So P transpose, that is event of not hitting the target, is 4 by 5. That is 0.8. There is 80% chance that they will not hit the target, but there is 20% chance that they will hit the target. That is what it means. Understood this problem? Everybody understood? Now, moving to the next question. In a lot of 50 items, 5 are defective. Okay, so to a factory, they are getting a lot of 50 items. Okay, in that 5 items are defective. What is the probability of selecting a defective item if one item is selected at random from a lot? Now let us say this is a lot of 50 items. Okay, out of this there are 5 defective pieces. Now what they are saying is, what is the probability of selecting this only? What is the probability of selecting this if I am randomly taking one of them? Sometimes it happens, no? The first thing, early morning, you will be running short of time, you want to go somewhere. Okay, you will take the watch, and if the watch has stopped working, so that is a defective piece. First, at once in the early morning, it has stopped working. So what they're saying is, the first event, if we are drawing one event, that event, what is the probability of it being? Yeah, Akila, I will explain about it, when to use it. Okay, don't worry. First, understand the question. Now, in all the problems, they asked us what is the probability of doing it, right? But in the question, whenever they ask you what is the probability of not doing it, then in that case, you have to use this formula. So if you see the previous question, they're asking what is the probability that the random card is ace? What is the probability that the random card is diamond? What is the probability that the random card is black color? So then we will use these formulas and find. But if the same question was, what is the probability of not getting ace? Not getting ace. This not if it is used. If there is a negative thing in the question, then you have to use this formula 1 minus P of A. Now, if you see this question, what we are learning now, in this question, there is a load of 50 items, and we are trying to check the 50 items, and we will take the sample. We will take one of the product as sample. Now they are saying what is the probability that this sample itself is a defective item. Okay, so out of 50 items, total number of items are 50. Out of that, 5 items are defective. Correct? Out of total 50 items, 5 items are defective. So firstly, say them. Let A be an event of selecting the defective item, and B be the event of selecting a non-defective item. Okay, so out of 50 total products, 5 are defective. So the probability of selecting a defective item is 0.1. So there is 10% of chance that we select a defective item as the first random piece only. Then how about the other part, that is P A dash or A dash? So the formula is 1 minus P of A. So 1 minus 0.1 is 0.9. So there is 90% of chance that the uh, that they will be selecting a non-defective item for sample, but there is 10% chance of them selecting a defective item. Did you all understand? If you try to understand it practically by imagining the scenario, only then you'll be able to solve it quickly. If not, everything will be going above head. It will be bouncing. Akila, I hope I answered your question also. Whenever they give you not happening, okay, in those cases, you will have to use this A dash. That is the opposite. Can we go to the next question? Now, a dice, this is, okay, die, if it is only one, it's called as like that. Actually, it is a dice, D-I-C-E, okay. A dice is thrown once. They're just rolling the dice once. What is the probability of getting multiple of 3, and what is the probability of getting non-multiple of 3? Now, if you analyze here, one is a positive question, the other one is a negative question, non-multiple of 3. Okay, so first let us define what are the possible outcomes. So let A be an event for getting the number that is multiple of 3. So first event A is a number for getting the multiple of 3, and then A dash is another event of getting non-multiple of 3. Okay, now the sample space in a dice, when I roll a dice, it will have 6 numbers, that is from 1 to 6. Okay, now what is the first one? This is A, this is not A dash. Okay, this is A. Now what is the first event? First event is getting the number which is multiple of 3. Now out of 1 to 6, 3 ones are 3, 3 twos are 6. These two are the numbers which are multiple of 6. Okay, now apart from this, rest all the numbers are non-multiple of 3. Only 3 and 6 are multiple of 3. Rest all the numbers are non-multiple of 3. So A dash will become 1, 2, 4 and 5 because 3 and 6 is already considered here. Okay, so the sample space, total sample space is 6. Out of that, 2 numbers are a multiple of 3 and 4 numbers are not a multiple of 3. Okay, now let us find the probability. Now P of A is, there are 2 possibilities of getting multiple of 3 out of total 6 numbers. I'm repeating it again. Out of total 6 numbers that is in the denominator, 2 numbers are the possibilities, that is 3 and 6 out of 6 numbers. That is probability of getting event A. What is event A? Getting the number multiplied, multiple of 3. Now coming to the second one, probability of getting a non-multiple of 3 is, there are 4 numbers under non-multiple of 3 and out of 6, 4 numbers are a non-multiple of 3. So 4 by 6, which is nothing but 0.6667. Understood? So here, especially in dice problem, please define the sample space, define the favorable events and then solve. Okay, in card problems, if you are getting confused, write down that flow chart. 52 and then 4 bifurcations, and then in that how many were there. Okay, so this is another problem where you will be calculating A and A dash. But here it is not 1 minus A. Why it is not 1 minus A? That 1 minus A we have done here. This, out of this, we have taken out, we have minused 3 and 6 and rest of them we have written it here. Okay, so there we have done 1 minus A and not here. Understood? Any doubts? Okay, we shall stop here for today. We'll continue in the next class. Okay. Yeah. Thank you, students.